In a three-phase transformer with a 480 volts primary and 120/208 volts secondary, the neutral wire on the secondary side must be connected to the equipment grounding conductor, or EG. This EGC is a ground wire that connects the electrical equipment to the earth ground. The National Electrical Code, or NEC, addresses this requirement in Article 250.5, specifically focusing on system grounding. 250.5 paragraph A, General, states that the electrical system shall be grounded as required by 250.21 and 250.23. 250.5 paragraph B, Equipment Grounding Conductor, clarifies that an EGC must be provided. Specifically, for a separately derived alternating current system that is not grounded, the EGC serves as the neutral conductor of the transformer or generator supplying the system. The purpose of connecting the neutral wire to the EGC is to ensure that all exposed conductive parts of the electrical equipment maintain the same electrical potential as the earth. This configuration is crucial for preventing electrical shocks and ensuring the safe and reliable operation of the equipment. You don't need to run two separate wires for the neutral and grounding functions. The EGC can effectively serve as both the neutral wire and the grounding conductor for the secondary side of the transformer. To reiterate, in a three-phase transformer with a 480 volts primary and a 120/208 volts secondary, connect the neutral wire on the secondary side to the equipment grounding conductor, or EG. This connection is essential to ensure the safe operation of the electrical equipment, as mandated by the NEC in Article 250.5. Proper grounding is a critical safety measure in electrical systems.